these are copper, and these copper buses are only, let's say, 18 years younger than me. Hey everybody, welcome back to the YouTube channel. Today, I think what I'm going to do is I started off thinking I was going to play some music, and then I thought maybe I'll spare your delicate ears and do something more electronic. Now, this is a somewhat historic electronic idea. I'm going to resurrect my CAT SRM synthesizer. Now this is a classic synth, classic in that it's old. I will add, I am the original owner of this synthesizer. I bought it back when I was in high school, many years ago, before many of you were born, and I think maybe Gerald Ford was president, or Bill Clinton, or Ronald Reagan, or one of those guys. Anyway, a long time ago. I bought this synthesizer new with money that I made working at Sears and Roebuck. I bought it at Bernadine's Music in Matawan, New Jersey. As you can see, this is the original box. I never had a road case when I played in a band. We were poor. I spent all my money on synthesizers and keyboards. I didn't have money for road cases or whatnot, so this synthesizer has been traveling around the country in this box. It's been from my original home in New Jersey, out here to the West Coast, back to the East Coast again, to the Carolinas, back to the West Coast, up to Alaska when we lived in Alaska, and now back here on the West Coast again, all in this box. We can see here, let's see if we can get a picture here. You can't quite see it. Here's the original shipping label from Octave Plateau Electronics. So CAT SRM was originally built by Octave Plateau, which later became Voyetra. They made a number of different synthesizers. This was their first polyphonic synthesizer. So this is basically a monophonic 2 VCO synth that you can play two notes at once if you're lucky. I actually almost never used it in that mode because in polyphonic mode it was very thin sounding. In mono mode it was quite fine. So this is the original box, and you know, we can admire all the little advertising, the CAT proof that at Octave we build instruments for the most important people in the world, you. I'm one of the most important people in the world having owned one of these. I will add that this is not original. This came from moving. One of the times we moved anyway. This is the original foam that was in there, and here it is. And can you imagine gigging with this? I mean, there have been many times when we've closed a bar, you know, closing time 2 o'clock. You start packing up your instruments, and I'd have to put this thing back in this box myself, because of course we had nobody helping us except the 4 of us, and here it is. So quite classic looking. Plastic keyboard. This is the pre-Fatar keyboard, of course. As you can see, we have two VCOs. We have a VCF. I actually have a schematic for it somewhere. We'll get into the schematic. But what we're going to do is I'm going to take this thing apart. Now, I have not plugged this in since probably sometime in the early 1980s. Here's it's a grounded connection, but I've got one of these gray things on it because I think most of the bars we played at didn't have grounded connections, so getting rid of hum was a perpetual issue. I have no idea if I plug it in, if it's just going to smoke. I'm guessing that every electrolytic capacitor in here is dried up to a potato chip. So we're going to replace all the electrolytics. We're going to clean up the bus bar that this thing connects to, and I'm going to look for any other signs of obvious damage to any of the components. You know, I'm imagining, again, I'm just going to outright replace all the caps. We're going to look at the board and see if the board needs any work. Last time I packed this up, it worked. I mean, I packed this up after the last gig we played in Jersey. Oh God, that would have been probably 87. And I don't think I've plugged it in since. And so we want to bring this thing back to life. It might work now, but let's, quote, bring it back to life by at least doing enough so that the power supply doesn't burn. Because I have a feeling if I plug this in, we're going to get smoke out of here. And then some of the transistors, or if there are any ICs in here, God forbid it uses any of the older ICs, we'll never find any to replace them. So we want to treat it nicely. I do have the alignment instructions. The beauty of the internet is all the alignment, all the schematics and everything I've been able to find. And so we'll go back, we'll use those, and we'll bring this thing back to life. So this is kind of an electro-musical video we're going to do. Okay, we get into the bottom of this little fiberboard by removing 8 screws, including the little rubber feet. And as we can see, caution, no user serviceable parts inside. Refer servicing to qualified personnel. I'd say anybody who's qualified to fix this is retired. And that leaves me. So when we get into here, what do we see? Well, we've got the board itself. I see some green wire in here. I am 100% sure I didn't do this because I didn't have the schematic for this thing. So this was modified after the fact in the factory somewhere. We can see, there's one, actually there's a couple of green wires here. Probably, you know, they got the board back and, you know, they decided they had to make some mods. There's some green wires on this board over here too. So this is over on the ADSR side. Let's make sure we know what we're talking about here. No, this is the voltage control amplifier side of things. And there's some green wire on there too, and some resistors on the back, etc., etc. We can see here there's these bus bars which are pretty tarnished. And the way this works is you press a key. And things fall apart. There's a little bit of foam in there. That's some of the packing foam from my thing. And you press these keys, and these little wires, there's two little wires that when the key is pressed contact bus bar. Each key, one presumes, kicks in one of these resistors. So as the bus bars hit, there's a certain total resistance that's kicked in. Actually, it's probably from this side because there's a connector here. All right, and then here's the main power board with a fuse, transformer. What I'm going to do is, I mean, these caps are probably God knows how many years old. All right, we're gonna take this guy apart completely. I'm going to take these boards out. I'm going to take the power supply out. I'm going to take the keyboard out. We're just going to leave it a shell, and we're going to try to. I'm going to make sure there's no electrolytics on the other side of these boards that needs to be replaced. I see quite a few integrated circuits in here, which are probably pretty prime material to if I wanted to part this thing out on eBay, but I don't want to part it out. This is mine. I've used it my whole life. Well, I used it in the early days. And look at these cobwebs in here. And so I have a certain attachment to it. I'd like to see it work again. So we'll take some more of it apart, and we'll get back to you when it's a little further apart. All right, let's look at what we got here. So this is the main board, and as you can see, we've got green wire in a number of places. So sometime after this thing was built, and this says this is Rev C 1, let's see, it's CAT SRM II. So they made some mods to this board after the fact. There's no green wire on this side. We can see lots of electrolytics I'll have to replace. Some of these larger ceramics are probably fine, but I do have replacements for them. And you can see the parts are all pretty standard stuff. Nothing outrageous. Things that we could even replace this, you know, with in 2016. We got here. The only thing that might be a little bit difficult is under these Tempcos, they've got a 3046. So this is probably an NPN transistor array that they're using for thermal stability. But I'll tell you, as I remember playing this thing, it was one of the most thermally unstable devices known to man. I mean, you know, you'd have to let it warm up for a half an hour, and even then, if a cold breeze blew over it, you were retuning it. So this is the main board. Oh, the other thing I'll say about the main board is if we take a look on the other side, see all this bubbling? It could very well be that many of these traces have cracked over the years. So I'm going to have to go through each of these traces with a continuity checker and make sure they're still good. In addition to swapping out the caps. Here's the power supply. This is a pretty nondescript power supply. I might even just put in a modern one. Although for no, you know, probably just replace the caps and it'll be fine. I could just as well use it. It's a plus minus 15 volt. That's what it is, right? Yeah, plus minus 15. And I've got these all over the place for my for the modular that I've built. Here's the VCA board. Now the VCA board, here's the VCA board right here. You can zoom in on that a little bit. Let's zoom in on it and focus. And you can see we got some green wire going on over here as well. So they made mods to this thing after the fact. And here's another Tempco glued on to something I can't tell because I can't lift it. It's probably another transistor array. Nothing unusual. The wildest part here is there's a CA 3080, which you can even get now. I've got a few of those for other things I've built. This board looks like it's in much better shape. I mean, because it's all been soldered over, right? So I think we're probably in good shape with this board. And the power supply, it looks like it's a gimme. There's, you know, I'll power it up and see what we get out of it. This board looks like it may need some work, right? So let's see if we can zoom in, focus, and zoom in on. That's about as zoomed as we're going to get on these things here. So you'll see this rippling effect over the board. I might have to green wire it myself. It's just dust other than that. we'll clean it up and we'll give it another shot. And I'll replace all these little blue electrolytics you see over here. So, you know, all of these guys, all those guys, all of these up here, all got to go. Everything else, we'll just try to go with it. We'll clean up these pots, these sliders, and we'll go with that. All right. And one last thing I want to show you is here's the keyboard. Keyboard looks like it's in pretty good shape. The main thing is that these buses, let's see if we can get a zoom in on the buses. And focus a little bit, baby. How about focus? There we go. And they're just a little tarnished, right? So we'll untarnish them. We'll rub them off a little bit. Other than that, I mean, this wire looks like it's seen better days contact-wise, but generally it doesn't look too bad. Alright, so we completely rebuilt this power supply. Left the transformer, new capacitors all around. I actually changed the 7915 and the 7815 just because I had a whole bunch of them. And I didn't have a smaller rectifier. I just had this big hunky one, so I just wired that in. We're going to use that one, and power supply is completely resoldered, and we should be good to go. Okay, on the bench here, we've got the CAT SRM fully dismantled in the mode where we can align everything. I've got over here the alignment instructions, ancient instructions. Looks like they were typed on a regular old typewriter and read in somewhere. Somebody digitized them over the years. Let's get a little focus here. I'm going to push the focus button. There we go. So we got the alignment instructions here. We have the board layout, and we have the schematics, so we can measure away. We can see here my little LFO light is blinking, as you can see, blinking away, as it has on many a stage in dive bars in New Jersey. What I've done is I have replaced every electrolytic capacitor, and then there were two rather ugly paper capacitors out here that were leaking. I left the ceramics in, you know, ceramic. There's ceramics they find in the pyramids, so I'm presuming that the ceramics are okay. Resistors are probably all fine. What I will do inevitably is on the places where you see these temp goes, might be kind of hard to see. There's a temp go here. And TEMCO meaning temperature compensating resistor, which they used in these days. Let's see if we can zoom into that. Can we zoom into this TEMCO here? Kind of focus. This is a high-end camera I'm using, and because it's so high-end, it's a pain in the ass to use. If only I had just had a regular old camcorder. Yeah, so there's a TEMCO resistor here, which is on top of these FETs. There are two more right here on top of this transistor array, and there's one on the other board over here, which you can't see. This is the VCA board. Essentially, they're trying to compensate for temperature. Does it work? Who knows? Let's see. So what I'm doing now, and I will zoom back out, and hopefully I can do this without, you know, the whole challenge of this is to do all of this without releasing the yellow smoke or the magic smoke from this sensitive device. So I've got the keyboard turned upside down here, and what I'm trying to do is follow the first instructions, which is to keep the voltage between the lowest key and the highest key, and everything's upside down, so I got to do everything backwards, to 3 volts. And we got 3.02 volts there. Raise this up. I got 3.02 volts on the highest key, and on the lowest key I've got basically 0, so I'm 0.02 volts off. Not sure that's going to matter so much in any way. So what I'm going to do is go through this alignment procedure step by step by step. I'm not going to bore you with the whole thing because Frankly, it involves turning a resistor, checking a voltage, turning a resistor, checking a voltage, and doing that ad nauseum. You can hear in the background the sounds. You've got to have an 8 ohm load on this thing in order to have all the voltages set correctly. I completely rebuilt the power supply. I just didn't trust the power supply at all. So I left the transformer. Chances that the transformer were bad are quite low. At these voltages, you're not going to have burned out windings or anything. But I replaced every single component on the power supply because I was just afraid that I just didn't want wonky voltages screwing up some of these old ICs. I mean, some of these ICs are probably not replaceable. And if I have to replace them with a modern IC, I gotta wire the whole thing. So I did go through the foil side of the board. You noticed it was a little crumbly. I noticed that crumbly looking substance on top of the traces on the board that I showed you a couple of minutes ago. Actually, for me, that's 2 days ago, but for you, it's just a couple of minutes ago. That's really just some kind of a varnish or epoxy, or it's not an epoxy, it's a varnish. And it's just, over the years, it's just wrinkled. The underlying metal is still intact. I tested everything. I've gone over the board. I found all the vias. Now this is vias. There's another issue. This is a double-sided board. This is a single-sided board. This one over here, this is a double-sided board. This board was obviously constructed before they had through-plated vias and through-plated holes, or else they had them, and in those days it was too expensive. By the way, I paid $600 for this synthesizer back when I bought it. I understand in today's dollars that's close to $2,400. So that just goes to show you, I bought this as a poor high school student working in Sears and Roebuck. So nowadays you'd have to save up $2,400 to buy this thing. I was not impressed with the quality of the build on this board. There were cold solder joints, and it's also pretty freaking old. So, I looked for cracked solder joints and everything. It seems to work. I am getting sounds out of it. We're in a test mode here, so, I've got the LFO going, and so what we'll do is I'll go through the realignment. I have resoldered all of the components on the board that look like they need resoldering. I have rebuilt the power supply, replaced anything that could go bad, which is typically the capacitors. They're all replaced. Everything else I've left. Any traces that looked like they were kind of coming apart, I've green wired myself. I've actually mounted some components on the back of the board because they were really awkwardly aligned here. And I'll get this thing aligned and we'll set it up and we'll listen to it. So the next time you hear from me will be many hours from now, my time, but for you, it'll be like that. Okay, now we've gotten rid of the crappy audio from prior times. I was using the audio. I didn't realize that I had my stereo mic plugged into the headphone jack, so sorry about the audio. I can't go back and unfix the machine. One of the things I'll show you, if we can flip it over here, is the, you can see the Arturia BeatStep Pro in the background. The interesting things here is the keyboard. And as you can see, the keyboard is basically, when you hit the key, you get these two little thin wires contact with these two buses, and it's a dual note polyphonic system. I can imagine that those two wires probably have to do with which notes being sensed first and which notes being sensed second. In any case, these are copper, and these copper buses are only, let's say, 18 years younger than me. Okay, so they're pretty gummed up. So what I did was I used a solution. I asked the wife, how do you clean copper? And the wife knows all kinds of things. And so lemon juice, you can see the lemon seeds in there, lemon juice and salt. Works very well to take the tarnish off a copper. So I painstakingly brushed all of these wires, and some of them I had to reform to get them to work correctly. Painstakingly brushed each of them with a toothpick, dry toothpick to dry it off, and a wet toothpick with the solution of lemon and salt, and the dry toothpick to wipe it off. And in fact, if you do any kind of watch repair or things like that, you use wood, you use heartwood, in fact, to clean off and polish the brass, little brass gear pinions. So I figured the same thing should work here. And let's turn it back over. So we're getting, let's see if we can zoom out any further. And let's see if we get more of that into the picture.